Hello, dear students in grade 8. In this lecture in mathematics, we are going to quickly go through what we covered in class during week 5 the previous week. We are still in our lesson, which is the square roots. We continued our objectives. In this lecture, we continued talking about how we perform calculations with the square roots. In the last lecture in week 4, we have seen how we can add or subtract square roots. In this lecture, we will talk about multiplication and division of square roots. Then we will expand an expression by multiplication. Finally, we will compare two square roots. How can we multiply two square roots? In multiplication of square roots, we have three rules. Let me start with the first rule. Rule number 1, which is a times radical b. If I am multiplying a, which is any number, a positive or a negative number, with a radical, the answer will be a radical b. So the radical will stay as it is and the number will become the coefficient of the radical. For example, 3 times radical 7 is 3 radical 7. 11 times radical 5, we multiply, it becomes 11 radical 5. For example, radical 11 times 7 is also 7 radical 11. Suppose we have, for example, here, like this. Let me write it here. Suppose we have, for example, 4 times 2 radical 3. We have a number multiplied by a radical, and the radical has a coefficient in it. Then how can we multiply this? We multiply the number with the coefficient. So we multiply 4 times 2, which is 8. So we write 8 as a coefficient, and we keep the radical 3 as it is. So if we have a number and a coefficient for the radical, we multiply the number with the coefficient. Now, let me erase this to continue. So, okay. So we continue in the second rule. The second rule is radical A times radical B. I am multiplying two radicals with different radicands. So we keep the radical and we multiply both radicands inside. For example, radical 3 times radical 7. So we keep the radical as it is and we multiply 3 times 7, which is 21. Radical 5 times radical 2. We multiply the radical with the radical, so we keep it 5 times 2, which is 10. 2 radical 3 times 4 radical 2. We multiply the coefficient by the coefficient. 2 times 4 is 8. Then the radical by the radical. 3 times 2 is 6. Now, rule number 3, also we are multiplying two radicals, but the radicands are the same. For example, radical A times radical A is equal to radical A, all of it squared, which is the squared cancels the radical and the root is A. Radical 3 times radical 3, we write it radical 3, all of it squared, which is a 3. 5 radical 7 times 2 radical 7, we multiply the 5 by the 2, which is 10. Radical 7 times radical 7 is radical 7 squared. Now the squared cancels the radical and it comes out as 7. So we multiply 10 times 7, which is 70. Now, it's very important to know that if we have a radical and inside we have many numbers multiplied together, we can get the radicand outside if it has an exponent 2. But we cannot do this if we have, for example, radical a plus b. If we have an addition or subtraction inside the radical, we cannot get the a outside or the b outside. We should calculate inside the radical. For example, radical 4 plus 9, we add 4 plus 9 inside the radical, so it is radical 13. Radical 9 minus 4, we subtract, which is radical 5. Here, for example, radical 4 squared plus a 3 squared. Can we get the 4 outside and the 3 outside because they are both squares? No. Why? Because we have addition inside the radical. So I calculate 4 squared is 16 and 3 squared is 9. So 16 plus 9 is radical 25, and the 25 can be written as a perfect squared as radical 5 squared, so it comes out as 5. Now, how can we expand or reduce an expression? It's very important to know that to expand an expression, we are getting rid of the parentheses in the expression. We have two rules here to apply in expanding an expression. We might have a parenthesis multiplied by something outside. This something might be a sign, a number, a radical, whatever. So if I have m into a plus or minus b, we multiply the first by the first. M times a is ma, then m times b is mb. This rule is called one for all. So this one is multiplied by everything inside the parentheses. The second rule, which is a parenthesis times a parenthesis. By the way, this parenthesis or this parenthesis is called a binomial since I have two terms inside. So here we are multiplying two binomials. We multiply the first by the first. M times a is ma. Then the first by the second. M times b is mb. Then the second by the first. N times A is NA, then the second by the second, N times B is NB. Let me solve with you two examples. 2 radical 3 into 5 plus radical 3. I first multiply, this is a one for all rule. 2 radical 3 times 5, here we apply the rules of multiplication we learned before. So I multiply the coefficient 2 with the number 5. 2 times 5 is 10 and we keep radical 5 as it is. Then positive times positive is positive. 2 radical 3 times radical 3 is 2 radical 3 all of it squared. So 10 radical 3 plus 2 radical 3 all of it squared. We keep 10 radical 3 as it is. Then we say the squared cancels the radical. It comes out as a 3. So we get 2 times 3. Now 10 radical 3 plus 6. This is a second example for you to solve in the same way. Now let me solve the third one using rule number 2, which is all for all. 3 radical 3 times radical 3. 3 times 1 is a 3. Radical 3 times radical 3 is radical 3 all of it squared. Then 3 radical 3 times negative 1. Positive times negative is negative. 3 radical 3 times 1 is a 3 radical 3. Now plus 2 by radical 2 plus 2 radical 2 plus 2 by minus 1 is minus 2. So this is the answer. Now I can reduce my answer. I can say that the square cancels the radical, so it comes out as 3. So I get 3 times 3 minus. Here I have negative 3 plus 2 radical 3. I can add or subtract them since they have the same radicants. So it is minus radical 3 minus 2. So the answer now is 3 radical 3 minus radical 3 minus 2, which is 9 minus radical 3 minus 2, and 9 minus 2 is 7 minus radical 3, and you have another example to solve. Now, how can we compare radicals together? Or before division of radicals. Division of radicals, we have two rules. If we have a fraction and the radicands are divided, I have radical A over radical B. So here the numerator has a radical and the denominator has a radical. We can write all the fraction A over B inside the same radical. So we can write it radical A over B. Or if it is a fraction written inside the same radical, we can split the numerator alone, we can write it as radical A, and the denominator alone, we can write it as radical B. Radical 7 over radical 12. 7 is a prime number, so we keep it as it is, and the 12 can be decomposed into prime factors 2 squared times 3. So here 2 squared comes out as 2. So radical 7 over 2 radical 3, which is half radical 7 over 3. Now, radical 15 over radical 6, we can write them under the same radical. Can we simplify 15 over 6? Yes, we can simplify both by 3. So we get radical 5 over 2. Now we have radical 25 or we have radical 36 over radical 16. Radical 36 can be written as a perfect squared 6 squared, and radical 16 can be written as 4 squared. Now, in the numerator, the square cancels the radical and it gets out as 6. The denominator also gets out as 4. We can simplify 6 over 4 and we can write it 3 over 2. Now, how can we compare square roots? To compare square roots, we might be comparing a number with a square root. We cannot compare a number with a square root until we get rid of the square root. How can we get rid? We should make it square. So we square both. We square a and we square radical b. So we get a squared and here radical b squared. Here we say the squared cancels the radical, so it is a squared compared with b. Now we are comparing numbers. If a squared is less than b, then a is less than radical b. If a squared is greater than b, then a is greater than radical b. Or we might be comparing a radical with a radical, and we have different radicands inside. Also, we square both, so we get a compared with b, and we can see all the solved examples. This was what we finished last week in square roots. Please watch the video well, and if you have any question, you can contact me. Thank you.